Hey, this is Mr. Janes. In this video, we'll be talking about the area and perimeter of circles and also parts of circles. To start, let's review some of the vocabulary words we should already know about circles, starting with diameter and radius. Remember, the diameter is the length across the circle from one edge of the circle to the other, passing through the center. In other words, the diameter is kind of the longest chord in the circle, and we refer to its length like that. The radius, on the other hand, is the distance or the length from the center of the circle out to the edge. So the radius ends up being half of the diameter. In other words, if the diameter is something like, 10 centimeters, the radius would only be 5 centimeters. Now remember, the radius is the same length all the way around because the definition of a circle is the set of all points equidistant, the same distance from the center. So no matter where you have the radius, it's always 5 centimeters. Now, the circumference is the length of the outside edge of that circle. So for example, the length from here all the way around the circle and back to the same place. That's your circumference. Now we've learned that the length of the circumference is whatever the diameter is, remember, straight across the circle, times the number pi, which is approximately 3.14. We'll write that as C, circumference, is equal to pi times the diameter. Another way you could view this is the circumference is twice pi times the radius. Why is that? Well, if the radius was 5 centimeters, we would have to double it to 10 centimeters and then multiply that number by pi, 3.14, to find the circumference. Why is it that we have to multiply the diameter times 3.14, or this number pi? Well, if we took 4 circles, laid them end to end, and then rolled out a circle onto that, we'd notice that the rolled out portion was a little bit more than 3 times all the circles put together. In other words, we have 1, 2, 3, and a little bit diameters, each of those are diameter, is 1 circumference, which is why we have to multiply the diameter times about 3.14, or that number pi, to get the length of the circumference. So if we were to actually use this formula, circumference equals pi times diameter, let's try that on number 1 right here. Let's see, find the circumference. Here the diameter is 22 miles. So if I was going to find the circumference of that circle, I would multiply pi, that number that's approximately 3.14, times the diameter, which is about 22 miles. Now there's 2 ways to write our answer. One way is to do it in exact form. That means we're not going to put the number pi into our calculator because remember, as we've seen before, the number pi isn't actually 3.14, it's 3.14159 and goes on for an infinite number of digits. So putting it in our calculator would mean we'd have to round it or truncate, chop off some of those numbers, and so it wouldn't be an exact answer anymore. So again, our exact answer, we're just going to leave it as 22 pi miles. It's exact. Now, let's say we did want to round and put in an approximation for pi. What I would do is instead, I would put a little squiggly equal sign here to show that I'm approximating, and I put 3.14 times 22 miles and get about 69.08 miles. Now remember, that's the length of the circumference, the length all the way around the outside of that circle. Pause the video here and find the circumference for the second and the third circle. Pause the video now. The answers will be up in 3, 2, 1. And here we are. For the second circle, the circumference is either 4 pi centimeters in exact form or 12.56 centimeters in approximate form. For the last one, watch out. The 11 doesn't refer to the diameter, it refers to the radius. So when you find the circumference, you're going to have to double that 11 to 22, or use the second formula we have here, 2 times pi times 11, and actually ends up being the same exact answer as the first one, right? If the radius is 11 of the circle, then the diameter of the circle is going to be 22. So in fact, you get the same exact answer as you did before. Watch out to your circle, whether you're dealing with the radius or the diameter. Now let's look at the area. Now area is a measurement of the space on the inside of a circle, just like this, right? Now the formula we have for the area of a circle is pi, and that 3.14 number, times the length of the radius squared. So that's the radius times itself. Now remember, we're dealing with the radius here, not the diameter. So that'll be the length from the center of the circle to the edge. Now we'll talk about in class why the formula for the area of a circle is pi times the radius squared, but for now, let's just use it with example 1. Back to this first circle here, now we're going to find the area. Now again, the diameter of the circle is 22 miles. Now you might be tempted to just write the equation like this, area equals pi times 22 squared, but wait a second. I said the area is pi times the radius squared, so actually we're not going to put 22. Instead, we have to remember that the radius is half the length of the diameter. In this circle, that's going to be 11 miles. So, to find the area, we'll take pi times 11 squared. Now, if I want to do this in exact form, I wouldn't use 3.14 for pi, because remember, that's not the exact answer for pi. Instead, I'm going to leave pi at the end of my number and just take 11 squared. So 11 squared, 11 times 11, that's 121. And I'll stick that pi symbol right in the end. And again, we're in miles. But wait a second. Before, we were dealing with length of something. The diameter, how long it was, the radius, how long it was, the circumference, how long it was. And miles made sense for that, or centimeters, or yards, whatever. But now we're dealing with the inside of something. So we're not going to deal with miles anymore, or inches or centimeters. Instead, area is going to be a square unit. So we're going to call this square miles, or miles squared, by putting a little 2 up top there. Now let's say you want this in decimal form. Remember, we're going to use the squiggly equal sign to show we're going approximately equal to. We'll use the number 3.14 as our approximation for pi times 11 squared. And you can pop this whole thing in the calculator once, or you could just do 121 times 3.14. And I found the area to be 379.94 square miles. At this point, pause the video and try to find the area for circle number 2 and circle number 3. Again, watch out for the difference between the radius and the diameter. Pause the video now. The answers will be up in 3, 2, 1. And here we are. The second circle had an area of 4 pi square centimeters, or 12.56 square centimeters in approximate form. And number 3, remember, number 3 is actually the same exact circle as number 1. In number 1, we had to cut the diameter in half to use the radius. Remember, pi times radius squared. But in number 3, they gave us the radius to begin with, so we could just do pi times the radius squared, or 3.14 times 11 squared, to get an answer of 121 square miles, or 379.94 square miles. Now that's all good if you want to talk about the entire circle, but what if you only want to talk about part of the circle? Well, here's some words we can use to describe that. We already know semicircle, meaning half of a circle, right? So semicircle is that half of a circle, maybe this half perhaps. And a quadrant, well, you might be able to guess, is a quarter of a circle, right? With that 90-degree angle in the middle there, right? It's a quarter of a circle. So those are different parts of circles, and of course we can have other kinds of parts, sixths of circles, 45-degree angles in circles, all sorts of stuff. But what's arc length and what's a sector? Well, a second ago we just talked about the circumference. Arc length is just part of a circumference. For example, if I had an arc from here to here, the arc length is the length of that part of the circumference. Now, what's a sector? Well, before we talked about the area of a circle, and a sector is just part of the area of a circle. So for example, if I maybe had a piece of pie like this, the sector is the area of that piece of the pie. Not the whole area, but just kind of part of it. Here's some of the formal definitions of each one of those. Remember, arc length, we're talking about the length here. And that's a big difference because before we were talking about how many degrees were in this arc. Maybe it's a 90-degree arc, 20-degree arc, 50-degree arc. But now we're talking about actually how long that is. So we will talk about maybe that arc is the 90-degree arc, quarter of a circle, but maybe it's 10 feet long. Maybe it's 3 centimeters long. That's arc length. Sector, again, the area enclosed by part of a circle, an arc, and 2 radii. So here's the arc, here's one radius, here's another radius, and the sector is that area. So again, we're going to be using units like square centimeters, or centimeters squared, or square meters, things like that. So how do we go ahead and find the length and area of just part of a circle? Well, it's actually not that bad. All you have to do is a little bit of dividing. I'll walk you through the first one. Find the length of the arc in number 4. So we're trying to figure out how long that part of the circle is. Well, if you think about it, it's a 90-degree arc there. It's just a quarter of a circle. So what if I just found the circumference of the whole circle and divided it by 4? That's exactly what we'll do. Remember, we're given the radius here. So the circumference of the circle is going to be 2 times pi times the radius, which is 11. But this time, once we find that answer, we're going to have to divide it by 4 because we're only looking for a quarter of that circumference, that arc length right there. So let's see. To do this in exact form, I will do 2 times 11, which is 22. I'm going to leave the pi. Remember, in exact form, we have to leave that and put over 4. I guess I could simplify that fraction. 22 over 4, that's 11 over 2. And again, I will leave that pi symbol there. So that arc length in exact form is 11 pi over 2 yards. Now, what if I wanted to do it in approximate form and get a decimal? Well, I do the same thing, except I can just put 3.14 in for my pi value. And, I might as well just punch the whole thing in the calculator because I'm going to get a decimal anyway. So 2 times 3.14 times, let's say 11, divided by 2, leaves me with 34.54 yards as that arc length. And there we have it. Now, let's try and find the area for that sector. So now we're going to find the area, how much two-dimensional space is filled in by that kind of piece of pie right there, that sector. Well, again, it's going to be the same exact thing we did before. Instead of circumference, we're going to switch that with area. In circumference, we used 2 times pi times radius. But with area, we use pi radius squared. In this case, the radius is 11 squared. And since it is 1/4 of the circle, we're going to divide whatever we get by 4. So, in exact form, let's see, that ends up being 121, it's 11 squared, pi over 4. Now 121 and 4, I can't simplify that at all. So actually, that's my final answer if I was going to leave this in exact form. What if I want it as a decimal? Well, I could throw the whole thing in the calculator and find that the area is 94.999. And there we have it. A couple little hints before we move on. This circle that we just worked with should have looked a little familiar. It's the same as both the first and the third circle we worked with before. So, since we were only working with a quarter of a circle, you could have just taken these numbers we had from before for the area and these for the circumference and divided them by 4 to get the area of that sector and that arc length. I'm going to have you pause the video in just a second and try number 5 yourself, but first a little hint. This is a 60-degree arc. So we want to think about how many times does 60 fit into 360? Well, actually, think about it. 60 is 1/3 of 180, or 1/6 of the whole circle. So the last one we divided by 4 because it was a quarter. Now we've got 1/6. Pause the video here and try to find the arc length and the area of this 60-degree sector. Pause the video. The answers will be up in 3, 2, 1. And we have that the arc length of that 60-degree arc is either 1 pi or 3.14 miles, and the area of that sector is either 3 pi over 2 or 4.71 square miles. Now, this third one's a little tricky because we're not sure what fraction of the circle 225 degrees is. Well, when all else fails, we can always remember that there are 360 degrees in a full circle. So really this is 225 degrees out of 360 total degrees. Now let me show you how we can handle that to find the length of the arc. We start with the full circumference, 2 times pi times the radius, which is 10. But instead of dividing by anything, we're going to multiply it by the fraction, 225 out of 360. On a calculator, we can enter it like this, and if you're using one of the black calculators, you get the exact form given to you, 25 pi over 2. You can also press the approximate equal button to get that number, and there we have it.